Doing a lot of these courses with contractors, I have asked them over time to tell me what problems you face. And this is the cost components section here. So we ask them, and the first thing they answer usually is not enough pay, not enough work, too short a season, comes up an awful lot. High equipment cost is a real concern. Labor problems are probably even higher than not enough pay in some cases, because the jobs are there to be done, but they can't get labor to do it. Some of them have all risk, no profit. There's insurance problems, workers' comp. The cost of Katrina is finding its way into other parts of the economy now, and some insurance companies are dropping coverage for higher risk kinds of things just as a result of that experience and others, plus the costs are being translated across all people who have insurance. So the insurance is a problem for many people as well. Timber, terrain, and weather, those are the usual thing. And then they find out that one of the big problems is government, and you can read that to anybody who's trying to provide direction and restrictions on what they do. So once we have that, we have to go back and think about the cost per unit produced, which is the value that we look at, and that cost is the actual cost of the operation plus the profit and risk that you have for the operation divided by this volume figure that we come up with, let's say on an annual basis. That comes up with dollars per unit volume, and it can either be big dollars in cost and big volume, or smaller dollars in cost and profit and lower volume. We get there the same way, and people who are purchasing services are just dealing with the cost per unit volume. So it could be the same whatever approach we take. When we start talking about our machine costs per hour, we start out with the initial price of the machine that we're going to be using. We estimate the salvage value because we drop that off of our calculations. We go to these hours that we were talking about yesterday and base our cost on scheduled machine hours or productive machine hours. For our purposes, we'll deal with everything on scheduled machine hours, and anything we have will translate to that value. We make a calculation of utilization, which is in the productive machine hours divided by scheduled machine hours, and that range is 60 to 99%, maybe. 99% is a brand new machine that's really effective and is a proven machine, etc., or one that's broke in and just doing right. 60% utilization, you almost can't make it at that. And the 75 to 85 is a common figure because of the downtime that we saw earlier. Well, we also have to estimate the useful life. And now we have to ask, are there any accountants in the crowd? If there are no accountants, I have to tell you, the bottom line with all of this is that you have to keep 2 sets of books. And by that I don't mean 2 sets of business books. I mean a set of books that allows you to make estimates for your business for bidding purposes and understanding your operation. You have to have regular books for accounting practices for your firm that allow you to pay the appropriate taxes, that allow you to take advantage of business opportunities like Section 179 depreciation accounts, where you can depreciate up to $200,000 of the first price of a piece of equipment in 1 year. Now that might be a good deal for you as a business, but it's not a good deal when you're looking at business planning for your operations. And so we don't have the same set of information that we want for these 2 purposes. So we're not talking in this particular course about the business that you operate in those books. We're talking about a set of books or information that allow you to run your business and manage it. The machines, the people, and the equipment, and produce a bid for the future for a job that you might do, and to track your activities from what you've done, relating it to the cost that you're experiencing. They're related for sure, because one of the best things you can do is to take last year's business books and put those into this year's budget for a longer budget and see how it works out. And in this case, for depreciation, where we're using up the asset value over time, may not be the same thing as what you have in your account books for depreciation. We use the straight line depreciation for our examples here because it provides a uniform costing basis for the equipment. The classic case of people who try to mix the two comes in with log truck operations. And so you have a person who buys a brand new log truck, and he can depreciate $200,000 of that cost the first year. And so he hires out at a particular price, and it looks like he makes a whole lot of money that first year because he's got a great depreciation expense. But the next year, however, when he uses the same rate as he had for his logging truck and has no depreciation expense, he owns a whopping tax bill. And so from that standpoint, that may not be the best depreciation approach for someone who's going to try to maintain a business over a 5-year period for a truck, let's say. So that's why these are different. The useful life is one we got to estimate, so is depreciation. And I just made the same statement that we are not, it's not the same for tax purposes as it is for our working course. Then among the machine costs, we have the expendables that we talk about, the fuel, lube, rigging, tracks, tires, etc. On the repairs and maintenance, sometimes the prior experience is a pretty good guide. So if you have last year's information, many people keep their costs by machine, and they can find out what the repairs and maintenance were for those machines, then they can use that number. If it's a new machine or a machine that you don't know anything about, there have been some studies, and I provided some of those examples in the references in the back of this book that talk about the rates and repair rates of different types of machines. Generally, anything that moves, wiggles, and wobbles and shakes has a much higher machine repair and maintenance cost. So that can be 50 to 80% of the operating cost of the. We usually make it as a percentage of depreciation. It can be up to 80 or 90% or even 100% of the depreciation cost. Things that are stable, like a chipper, where the things are the only thing that's moving is the knives and the rotating structures. Those typically have less repair and maintenance costs, for example, than things that are moving. But we have either actual amounts or we estimate. Taxes, insurance, and we treat the interest as the percent of the average annual investment. Now, I should say something about average annual investment. When you buy a house, you ever look at your house payments and you find out for the first 10 years of your house payment, all you're doing is paying interest. Okay, the next half of the time period, you're getting the interest goes down a whole bunch, and you're paying off on principal. If you take the average of that value of the house, that's your average annual investment, and that's what we do with equipment as well. For the first 2 years of a 5-year life, you're paying all interest. The next, you're paying on principal. So we take the average annual investment and say, what's the interest on average for that equipment for that year? That's how we calculate that for our machine costs. And we have to talk about this price basis for estimation. If we are using what you pay for equipment and you buy used equipment, like I said before, you're setting the sector up for a stage where you're buying the pricing that you're having for the services recovered by the machine price as being the last logger buying the last piece of equipment from the guy who just went out of business. And that doesn't really work. If you use 10-year-old equipment prices, you'll get all the bids you want because you're underpricing your equipment. You'll have a bidding advantage. But you won't ever accumulate money in a depreciation account. And I mentioned before that when I ask loggers about the money that they have in the depreciation account, most of them are empty. It's because they're having to use them for operating costs for their business. because they're not properly estimating or using a cost when they're pricing their machines. And that's a real problem. Not only, even if you do it right in terms of using current prices for the equipment, you will find that by the time you go to buy something new 5 years hence, the annual price of the equipment increases has been 7 or 8% a year. You still have to take out a second mortgage on your house to be able to buy a new piece of equipment. So you have to at least get what you can out of the depreciation accounts. The other thing that we do is we recognize is that there are different productive capacities for different machines, and they perform differently. Here are some examples that we have for the 3 machines that we saw earlier, and they process trees at different rates. So not only do you have to have a price component to work with, you have to have a productivity component that comes into play. So we'll talk about that a little later, about how we estimate what production rates are. Here is an example of the production rates that we have for some equipment, and we saw this yesterday. This is on page 7 of that section, and these are those 3 machines that we saw in some of our graphs earlier. This is for felling and bunching, a Rotney machine, a John Deere machine, and a Caterpillar. And I mentioned the names, but I don't endorse any of those companies. As I said earlier, we don't endorse one machine to the exclusion of others. When we go through our systematic approach to costing, we'll see how we get to the bottom line. But if we estimate the life of the equipment as 5 years, we're going to have a salvage value of 20% and an interest payment of 10% on the money borrowed to buy this equipment, insurance and tax rate of 4%, we find that we end up having a cost per scheduled machine hour of these values. And they're different by different machines. And it depends pretty much on the price of the machine with the same assumptions. So if we have the same assumptions, we get the same ownership costs of the machine. When we come to the operating costs, we have to make some other assumptions. And here, as I said before, the repair and maintenance percentage was quite high in this study. And that was in part because these were brand new machines in a new application. And there were lots of problems, so the estimate was set at a fairly high level. We also consume fuel at a particular price, and the lube is oftentimes a percentage of fuel costs. On machines that do a lot of movement, it's not uncommon to have the lube be 50% of the fuel price. Now, as this fuel price skyrockets, that percentage should probably drop back because lube and other expendables haven't gone up at the same rate as fuel. We have operators' wages and come up with a total scheduled cost per machine hour of these values of $136 to $126. We'll see how we calculate that when we get into our operations. That translates then into different production rates with different delays for different operating conditions. And given those same 3 machines, we studied them 3 different ways. We studied them in a detailed time study operation. And that's this green bar here, where we would go out and take detailed samples and measure the elements, time them out, and see how much it cost to do this particular task of cutting standing green trees that were 7.1 inches average in diameter, with delays and the mix and so forth that we have there. We find that they performed at different costs. What we also learned is that when we did shift level estimating of production, the cost went a whole lot higher, because when we're out there doing detailed time studies, we miss a lot of the delays. They just don't happen while we're there. And so you have to be careful reading reports about machinery and equipment so that you look at what were the shift level results, not just the detailed time study.
But doesn't the operator perform better too when he's been watched?
There's an effect from the bias from investigator effect and stuff, but oftentimes we're sneaky. We hide, and we they don't know what we're looking at and so forth. Sometimes the details, time studies are done by a camera, and so we'll videotape a large section. Well, it happens, but these estimates differ depending on how we collect the information. Here's another set of machines, a forwarder, and you can see the forwarders are less expensive and they have lower operating costs. I don't know if you've got that in there, but it results in different production costs as well for these machines. And one of the things we did with the forwarder was try to estimate its cost by putting a GPS machine on it that would allow us to track its activities. And in the future, a lot of the machines that we saw, you'll be able to get detailed information by looking at what happens to the machine function. You'll get a printout that will allow you to see what the machine was doing each time and where the machine was. And our study of these machines become a little more effective. But for the moment, we get the highest results generally by shift level time studies, but not always. So the other part that we have in our cost picture is the wage rates that we have for our operations, but we have to account for the labor as part of our calculations, so we'll see that. Holidays, vacations, Social Security, any retirement plans that are available are part of the fringe benefits. We used to, in the logging industry, have fringe benefits that would run about 47% of the payroll. With changes in the structure, those have gone down to about 30%. So people are paying less benefits and to additions to wages. So that's a concern for a lot of folks. Medical health and so forth is a real problem. What has happened more recently, however, is that's beginning to trend back up, because in order to recruit people away from other occupations that provide higher wages and better benefits, they have to provide more amenities. Oftentimes it's vehicle use, sometimes clothing, other kinds of things. One of Al's problem was that he talked to his guys and he said, well, just take the gas you need to get to the job site. Well, pretty soon they were carrying 5-gallon gas cans in the back of their rigs going home at night. So he started looking at his mileage for some of his vehicles, and the pickup was getting about 3 miles a gallon. It wasn't quite right. So after we do that, we also have to look into the workers' compensation effects. And from our standpoint, we know that your business is dangerous. For the most part, it's a targeted industry, and so subject to increased enforcement. Utah is a federal state for OSHA, so you don't have a lot of OSHA inspections here, but you have OSHA rules, and the rules will come into play if you have the fatality. And I can just about assure you, you will have broken rules if you have a serious injury or a fatality. It's almost a certainty.
Could you repeat that part about the federal relation to the state relation?
Well, there are some states that have a state plan. And as an example, Oregon had, before there was ever federal OSHA or the Occupational Safety and Health Act of 1970, Oregon had an accident prevention division that was charged as a state agency with reducing accidents. And the industry as a whole demanded that agency work at policing the industry. In 1942, 200 loggers were killed in Oregon, and that was unacceptable by anybody's measures. It was probably as bad in Montana, Washington, and everywhere else. It's just that they had the numbers that showed up. And so that number has been reduced periodically over time to where it's down to 3-4 annually in Oregon. But Oregon had this accident prevention division and a set of codes that were safety rules before federal OSHA. When federal OSHA came in, Oregon also put in a Safe Employment Act that said we will exceed the OSHA standard by our own rules. And so Oregon, Washington, California have their own rules that exceed the federal standards and are able to set their own rules different from federal OSHA. We self-regulate in Oregon. It's a state agency. It's not self-regulated by the industry, but it's regulated by each state. Idaho, as a state, has a set of rules that they agree to represent the rules for logging within the state, and the state passed rules, but they are still a federal state in terms of OSHA enforcement. So that's the difference. Let me just talk about the different classifications, because we mentioned that yesterday, in that there is a mechanized harvesting rate where Oregon had a rate of about $34 per $100 of payroll for logging generally. When we used the mechanized harvesting rate, it was down around $22 per $100 of payroll. So there's a real advantage to taking, the reality of it is taking the chainsaws away from people and putting them in cabs. And then each job that you do has a different rate. So if you go out there and you're cruising timber for the day or planning the operation, you put in a different rate for that hours of time, and you pay workers' comp separately. Many folks are not very careful about that and overpay workers' comp by those classifications. Trucking has a classification, as does maintenance. So in a logging operation, you need to be sure you have people classed according to their different rates.
And they would, a typical person might switch, be doing maintenance one day and following another day. So different rates can apply during different days of the week.
Sure. You put it down on a timesheet. You put the classification down, and then when you pay your tax, somebody has to go back in there and compute the hours at different rates. So that's why the computer makes it a whole lot better, for record keeping and the like. I should compare the workers' compensation for other countries, because it's different. In most of the states, each sector or each industrial classification has its own rate. And so the rate for me as a college professor was about 23 cents an hour, something like that, whereas people who were logging were paying $34 for $100 of payroll. So it was really different. Some countries, the Nordic countries in particular, everybody is under the social welfare insurance. And so this rate is charged to the whole society and is a part of their tax payments. So the unsafe workers are subsidized by the safe workers. And so when there's indication of a lot of worker health problems and safety problems, society as a whole comes screaming in on those areas and saying, hey, you guys are costing a lot of money to the system. You've got to change it. And so there's a lot of social pressure to bring those costs in line. That's also true in a place like Chile. Chile is a developing democracy, but they have made a decision that everybody will pay for the cost of the industrial base. And so they say we don't need people in offices unless we have productive capacities elsewhere: agriculture, forestry, mining, and fishing. And so people are going to pay, everybody's going to end up paying for having these basic industries. And so again, they also put pressure for safety in those industries to make them safer. Whereas in our circumstances, where the industry pays what it experiences, the rest of society doesn't get all excited. And so it becomes a forestry problem or a logging problem, and not one that society deals with directly. So there are differences from that way.
So what about accident rates? Are they safer?
Those countries have significant reductions in worker health. Accident rates are somewhat probabilistic in nature, so you still have a number of accidents that occur. But in the Nordic countries, where they've moved to all harvesters and processors, about 90% of the wood harvested in Scandinavia is done with a harvester and a forwarder. Their accident rates are very low. Their health rates are higher, in part for some of the things that we talked about in the forestry sector: back and shoulder, muscular injuries, maintenance injuries, and the like are high.
So what kind of rates do those companies have in comparison to ours?
The insurance rates and stuff? In the socialized countries you can't tell because all of them are lumped into the tax rate. Their overall tax rate is about 50% of income. So in Norway, Sweden, and the like, you pay 50% of your income into taxes.
Are they still credit grade kind of care? Is that what they're doing?
Yeah.
That whole thing?
Yeah, you have all those social benefits until you die. In Chile, we had one figure that I think averaged across all occupations was about $4 per $100 of payroll, and so it was quite low compared to anything else. They also have their mutual insurance companies is tied in with a savings plan, so that you pay into this as well as getting health insurance. For that, you can pay into it as an investment to a mutual company. And so the mutual companies work to get insurance costs down. They have their own hospitals. So each insurance company has its own hospital for workers sometimes to keep the costs down. It's a different way of looking at it. Even in this country, if you do well in workers' comp, you can get rebates. And so some folks have instituted incentive programs for reducing accidents so that they get these rebates. This is a trend as it was in Oregon for a period of time. We got as high as $45 per $100 of payroll, and then instituted a series of reforms and improvements that brought it down. Now we're going back up. And part of that going back up is a result of changes in the workforce and also just the cost of medical activities. A knee is $100,000.
Is this one of the things that contributed to the West Coast operators' mills going out of the company logging operations? Was this trend about this time?
I think it had a effect, but those companies were self-insured. The accident rate for the industry as a whole, for industry in Oregon and for logging, is about 8 serious disabling injuries per 100 workers. The privately insured companies like Weyerhaeuser and those folks had a rate that was below 1, and they have a goal of 0. They still have some company crews, and they pay very little for accidents in the companies. They're self-insured, but there's very little payment for it because they really push preventive measures. These rates that we see here were average. An individual firm could be higher. Once you reach about $54 per $100 of payroll, all strange things begin happening. A bunch of subcontractors begin showing up on the job. A bunch of name changes for business operations take place, and all sorts of games start getting played, but it doesn't work. They pitch you out.
We're up to about $67 period. And almost no money on the books in logging.
Right.
Hard to face it, trying to get rates reduced.
Well, the rates are determined by the National Council on Compensation Insurance, and it's based on your experience. When you have few people and a few get hurt, it sets the rate for everybody at a very high level. And that pushes everybody to being subcontractors. And in Oregon, we have a generalized rule such that you can't have a bunch of subcontractors. The general contractor ends up being forced to pay the workers' comp if they find people playing that game. And they do it retroactively as well. So it becomes a huge penalty to do that. But West Virginia has the same kind of problem. They ended up being at that rate, $67 per $100 of payroll. That's why they went to the Feller Butchers that we saw in our earlier example, where they were able to reduce it by quite a bit. Hawaii is $80 in logging per $100 of payroll.
Did West Virginia then get recognition for mechanization and getting the rates lowered?
Yes, but they get it the way these insurances work. It's on a rolling average, so you can improve this year, but you won't feel it for 3 years because of the way the rolling average is built into these rates. You will feel it. And that's the difficulty with something like safety and health, is that it can't be an individualized firm activity to bring down rates. It has to be a whole industry sector effort. Otherwise, the industry sector pays for the bad actor. The one bad actor that gets assigned the rate will bring it up for everybody. And then there's also the probabilistic nature of logging work. You do have some bad accidents periodically, and you really have to work hard as a whole industry sector to remove those by training programs, by inspection programs, and the like. And in West Virginia, they had terrible timber falling practices. I had several cases there, where people would be cutting a tree and said, "Oh, there was so much pressure for production, I couldn't see that there was a tree hung up in the one I was cutting." Come on, guys, that's dumb-dough work. Or there's a big hanging widowmaker right above where the guy's cutting, and he wouldn't look up, to take advantage of it. That's an individual training issue and an individual response for personal activities that comes into play there. There's no rules that are going to save people from that kind of activity. Well, this gets expensive, and it'll put you out of business. As I mentioned, you've got the wage rates for Oregon by region and so forth, and by job type, and you can see how they kind of average out. There are other costs associated with this running your business, in that you're going to have to pay for physicals, drug tests, getting the people. You got this issue of trial and error and learning. Right now, for choker setters on cable operations in Oregon, it takes about 5 false starts before the firms will find someone who's willing to work that hard for that amount of money, and it just is really difficult to find people. And that's where you have this job change premium for machine operators, up to about $2 an hour for these operators to keep them rather than lose their productive capacity. Some people use incentive systems that you can build into your wage structure, which has a good idea and a concept to it. Here's one example where the individual is paid less until their productivity comes up to the expected level, and if they produce more, then they get paid more. And so if productivity is above average, they get more per unit dollars. Now, a lot of folks pay on a piece rate basis, which automatically has this built into it. This was one built on an hourly basis within a company. So people use different approaches to provide incentive systems. Well, then the other part that is a part of our cost structure are the overhead costs. And when you run a business, you're going to have office facilities. You may have to have a bookkeeper to do the books and account for the loads. You have a taxes accounting and stuff that you have to pay for. You have this general labor and personnel administration, the supervision that isn't tied to a specific on-the-job activity, the management activity of the owners. The guys now have to put a security watch out there. You got $1 million of equipment out there, and if it's where not behind the lock gate, you'll find it shot up, burned up, or something if you don't have security. Shops, building, maintenance, low boys to move the equipment, trailers that you have to have, are all part of this overhead cost. The business debt service that you have for your operation, legal costs, fines and payments, extraordinary payments. I had a friend doing business in Colombia, and when he first started doing business, he would go to the woods with a bag full of money, and he would drop his bag full of money off just to get out of the woods. Pretty soon it was 2 bags of money. Then the time before that, the last time he called me, he said, "I went to the woods with my 2 bags of money and a Suzuki, and I walked home. Can you tell me if there are any job openings up your way?" And that was extraordinary payments. So all of this overhead comes in as part of it. Now, on some firms that I've looked at, that percentage as a percent of overall income can be around 10%, 12%, something like that. It's not a huge number, but if you don't include it and it's not recognized, where do you recover it? So that's our cost structure that we've got that has all of the costs that we've been talking about.